Hello, everyone. We are still here talking about energy, renewable energies, and energy saving in applications related to second level energy, that is, ground energy. We had a conversation about refrigeration units, and there is another area where significant energy savings can be made, which is the domain of free cooling or even evaporative towers. Let me explain. When are free cooling or towers used? When we need chilled water for an industrial process at higher levels, maybe above 30, 35 degrees, that is when we can use a cooling system that is not a refrigeration unit. We can utilize an evaporative cooler, a free cooler, a dry cooler. The advantage is the lack of compressors, resulting in energy savings related to refrigeration and machine complexities, refrigeration circuits, and the use of Freon. Where are these savings implemented? In this case, it is very simple using fans with DC motors, that is, motors with electronic control, therefore with integrated inverter, or in any case with inverter. Why is that? Why do we usually adjust the temperature? That is, we have a probe that senses the water temperature. We set a set point, and based on that set point, we adjust the power needed to remove the energy. In the past, when, let's say, the cost of inverters or EC electronic control motor was very high, one might opt for multi-fan solutions, thus adjusting in steps, partitioning the number of fans in operation in order to limit the power required at that moment. The present expenses of electronically controlled engines enable a reimbursement of this kind of investment in a remarkably fascinating period. Obviously, it's always worth doing a check, doing a control. I see, however, that more and more often customers are asking for the alternative and embracing it. Why? Because it allows for actual energy savings. It also allows for significant savings in terms of maintenance costs, because it is clear that if instead of running the fan at 100% speed for 6 or 9 months a year, it runs at a lower speed, its level of wear and tear is also lower. Besides wear and tear, maintenance, we have energy savings, and thus the solution with motors and electronic control, hence with inverters, is now mature and can be widely adopted for temperature controls, making it a viable option for efficient temperature management, especially on temperature controls, cooling systems, for industrial applications or conditioning applications that need to work 365 days a year or always. It is clear that if it is a plant that only operates in the summer, maybe the payback period of my investment will be a bit longer. But even in that case, it is always worth analyzing it. Because during the night hours, when the temperature drops, clearly we can modulate the speed of the fans because we have a higher efficiency of the heat exchanger. So maybe we need less air and we can run the fan slower and recover less. Interesting, this topic. Yes. Good day. Thank you.